So looking again at our schematic here, this is the sync separator, sync amp, and this is the AGC, the keying AGC side of the tube, and pin 3 is the plate. We should see 25 volts there, and at this point we should have a waveform that looks like that. 385 volts, 380 volts, peak to peak. And basically it's just a sync. We're seeing the sync pulse. So let's go to, where are we here? This is it here. That's pin 3 over there, which would be effectively this. That's pin 3 of that tube. And what do we see on the scope? We absolutely see exactly what we should have. That's the voltage. The peak-to-peak voltage is 329 volts. So I guess that's in the ballpark. The frequency is correct. It's 15.75. And DC volts. It's a weird thing. It's a negative 2 volts. It should be a positive 25 there. So, yep, I don't know. That's why I'm wondering if some of these capacitors aren't, if this 4 microfarad. The AGC works, the AGC control works fine. And that's our test point. We have effectively that waveform. But we don't have 25 volts here at this point. So I'm wondering if this is leaky or if this is leaky. That would certainly crush that. And let's go to our, this is our test point right here. This is our test point D. This should definitely be 25 volts because that test point is on the top of the circuit, top of the chassis, but it's inaccessible. But that's where it is underneath, and you can see that right by the probe tip, I had snipped that resistor lead and checked the resistor. That's 680K, and it's fine. So I hooked it back together and soldered it back into place. So at this point right here, we should see 25 volts. It's a negative 1 volt, negative 0.8. So I'm confused by that, and we're gonna get in here and see if we can solve this. We'll go one at a time. So let's start by replacing these 0.15s here and here. That would be here and up there, buried in there. All right, just for giggles, let's test this. Got it hooked up to the meter here. Well, so that's what it is. It's reading high, so it should be a 0.15. It's a 0.28. The ESR is 14 ohms. So let's check that against new component that we're going to put in here. All right, so let's test it over here. Well, yeah, there could be a lot of ESR. This could really not be a good capacitor. I don't have any way of checking leakage, not really. I can pull out the VTVM, and maybe we'll do that, but we're gonna go ahead and change this out. This seems to have a pretty high ESR, and an ESR meter, that's not a high enough capacitance to use an ESR meter. All right, so let's turn it on. We just changed one capacitor. We have our tuner lighting up. So we changed that cap right there, that one. And then this one is next on our list. So as this thing warms up, we're gonna see our neon light indicate that we have vertical sweep. And then we should have a picture in just a second, which we do. All right. So what are we looking for at this point? Let's take our probe. We're on voltage. We're just looking to see what's on pin 3. Well, that's a change. Let's see if change the range, DC range, pin 3, minus 22 volts. I think that should be a positive voltage. What do we have here on our AGC point on the tuner? Minus, well, that's considerably more than we had before. We had a couple of volts below that. You know, I was looking through the Zenith book and I just can't really find any indication of what that voltage should be at the AGC line. But this is interesting. I didn't really expect that there would be a difference like that. Let's adjust our brightness up or down. We got our contrast up or down. We'll go here, go there. Let's look at this. You know, it's really bright out now. Well, this is the cap, and it's in this solder cone here that's underneath this 47, what is it, 47K? No, 470K. And I think what we're gonna do is we're gonna snip the lead off of this capacitor. Sometimes you just have to make a decision not to try to get it out of these solder cones. It's just sometimes it just does more damage than it's worth. So we're going to snip, keep some insulation tubing on it, and then we'll solder from there, and then we'll probably have to extend our lead again, I would think. We're just gonna check the cap we just snipped out. There we go. Checking. Well, this one reads about the same as the other one. ESR of 14 ohms. A value, capacitance value of basically 2.8 microfarads. 0.28 microfarads. So that's, yeah, it's about the same as the other one, that one right there. So we're gonna go ahead and change it. If I was gonna just check this one for fun, the new cap. Testing. Yeah, okay. All right, so that's what we're gonna do. Yeah, this one might have lost this other one. Both of these may have lost their salt as capacitors. So we've got to pull this shrink tube back a little bit, make a hook on it. And then we'll make a hook here. I believe it's long enough. Yeah, it'll be long enough. Kind of a stretch. Activating. Yep. Activating vertical circuit. Activating. Television working. All right, so here we are. Let's check our pin. Well, let's check our test point here. This is test point D. Same result. One must be careful because yeah, you don't want to ground it. Let's go to pin 3. Well, we're supposed to have 25 volts, positive 25 volts, but for some reason we have 22 volts negative. I can't explain that, but it seems to be closer to where it should be. Let's look at our AGC voltage, see if that has anything to do with anything at this point. Too bad there's a wire in the way. Hold on. Negative 1.8. Well, that's way more than it was before. And I don't know what it's supposed to be. How's our picture? Let's look at our picture. Again, full on daylight now. But it surely looks good to me. The next thing we wanted to do is change out the 4 microfarad cap. This is now I got a 4.7 at 350 volts. We're going into the cathode circuit of the AGC, keying AGC amp, 4 microfarads, and it's, well, it should be like 100 and something volts. Let me check. Well, okay, so this is C2, and it's a square symbol. So here on our list of electrolytics, C2 was a multi-section cap. In the 2 4 microfarad sections, there was a 350 and a 150. This particular one is a 150. We're going to replace it with a 4.7 at 350. Just because we can. There's 2 capacitors up here that were part of the big multi-section cap. So let's go. It's kind of hard to read some of this on the SAM, so we pulled out the Zenith schematic. And it certainly is interesting to see how the same circuit can be drawn in a completely different way. But what we're going to do right now is look at this. One of the caps up there we're looking at, it's a 40 up there on, up here, that one right there, is a 47 microfarad at 35 volts. So that one should be fine. We might replace it anyway. And then the other one in question is in here, and it is this 4 microfarad at 150. So we have this capacitor, 4.7, the Nichicon, nice cap, 4.7 at 350. We're gonna replace that other one with this one. And what we can do is put it right here, because one side of this AGC pot goes to pin 1. This yellow wire from pin 1 goes up there, here, and it connects to that capacitor up here. So what we're going to do is, eventually we'll snip it there, and we'll snip it there on pin 1. But you see that at pin 1 goes all the way over here to the wiper of this AGC pot. So we're going to go from the wiper of the AGC pot to ground, like that. And that is that then. That's what we're going to do. This cap is in now. 4.7 at 350. Should be way, way, way overkill. Let's turn on the set. Yep, let's power. And this will be successful. Once it's successful, we're going to pull this wire out and snip off that old capacitor. So we should have some vertical starting pretty soon. Yes, we do. And television. And television. There we go. All right, so we have a successful picture. How's it looking? Pretty good. All right. And let's check our voltages. Let's grab our probe. Yeah, don't do this with your shoes off. It's probably a really bad idea. So we're gonna check our pin 3 right here. And well, we have about what we had before, maybe a little bit less. Minus 18 volts. I wonder if brightness affects it. Let's turn the brightness up. Go back to that. Turn it down. I guess so. Very interesting. What happened to our brightness? Did we turn it down too much? Yes, we did. Contrast. Yep, so I replaced that capacitor that was here, 0.22, another one of these Johnny Fast caps, 0.22 at 200 volts. Testing wise, high ESR, 11 ohms, and 1109 nanofarads. So what is that? It's like, it's gone up in value, 1.1 microfarads. Yeah, that's right. So anyway, it's wrong, so we're going to replace it. We did with this. And we've got 2 others we're going to replace. These 2, we might as well. We've come this far. I think we've replaced just about every capacitor, if not every capacitor in this. So these are in the audio circuit. 0.047 and a 0.0068. Again in the audio circuit. So we replaced that one. We are going to replace this one. Also couples the other speakers, the electrostatic speakers, and then we are going to replace the 0.068. There it is. It's a bypass cap to ground. This one right here. 0.0068 bypasses to ground the audio. So that one, we did that one. We're gonna do that one, and we're done with the audio circuit. So let's get at it. So what are we gonna do? How are we gonna do this? We're gonna snip the leads and solder onto the leads. That's what we're gonna do. Okay. Recapped the audio circuit. So we got all that done. Let's turn it on. Let's turn it on. Turn it on. Turn it on. Plugging it in. Turn our soldering iron off because we're confident. Turn this on. Yes, we have power. Warming up, warming up. It's gonna be really bright. It's gonna be hard to see this at this point. Let's see if we have vertical starting up. Vertical starting up. Vertical starting up. Vertical starts. Television. Look, everything we have done on this set has made incremental improvements. So let's check our pin 3 again. This should be, well, it should be 25 volts, but for some reason it's a negative 20. But before we had negative nothing, so I don't know. I guess it's working. The AGC here has minus 1.8 volts. If we go off channel to a point where there's snow, what you'd expect to see is a reduction in voltage. It's actually a positive 0.4, 0.5 volts, which would make sense. when we're on channel and we have a strong channel, we would have, where's the, which channel is it? Where are we? It's right there. When we're on channel, we have a strong channel, so you would want to have negative voltage there to reduce the gain of the RF system, the IF system. So I guess it's all working right. Yeah, just getting, I'm just sitting here in the driveway and I'm trying to clean these chassis up. This one cleaned up kind of nice, aside from my shadow. The sun just came out. It wasn't out a minute ago. So this is the Space Command chassis. All fine. Shielded on the bottom. I'm just gonna, yeah, I've just been hitting it with this, where is it? Nice. This. Start by knocking the loose stuff off. But don't just do it haphazardly. I really try to pay attention to what I'm doing. So I shouldn't be doing this talking and stuff. But you just don't want to break anything. Okay, I'm in my own way. And I have no idea why I'm sitting on the driveway doing this. I have plenty of tables and a workbench. But that's what I'm doing. It's a beautiful day. I was listening to the neighbors argue about their political campaign they're going to help out with today. I see two electrolytics, this one and this one. One is a 4 microfarad at 200, one is a 10 at 350, and then these two guys, a 0.047 and it looks like a 5 at 50. So, yep, just, I really want to make this chassis work, the Space Command. I've got another Space Command set that I haven't restored yet. It has a 600, Space Command 600. And yes, in modern world, you don't need channel changing up or down. That is irrelevant. Volume up and down is just kind of fun. And I was just trying to think of what we might be able to do with those other two channels. The channel selectors up and down, if I can somehow interface it with an infrared remote and use it to change the channels on a cable box or something like that. I'll come up with something clever. But and before I wrap this up, I just noticed how interesting this is a mechanism that toggles. It's hard to see, I think, but it toggles. I guess it's an on and off situation. I don't know. I thought this was the one that turned it on and off. Hard to see it because the controls are on the front side. But look at that. It's like a rocker switch. So this solenoid comes down and the rocker switch moves, and this little arm is spring-loaded and switches it from one position to the next. I'll have to look into that and see what this actually does. Awesome. Super clever stuff. Okay, I was just fooling around with it some more. That appears to be the sound muting switch. Yeah. I think that's the sound muting switch. Still clever as it can be. Look at how clever that is. Just cleaning some of these controls while I could. Squirted some stuff in here. And some stuff in this one. This is kind of like an 8-track head switcher, track switcher. That's the way they did it back then. And then there's this. Well, this is getting close to the end of this project. What we're looking at there is the Space Command 400 chassis. It worked at first when I hooked it up, and then it slowly stopped working, and I've been at it for a few days trying to figure out, first of all, how the circuit works and how to make it work again. So right now it's turned on, and if you could imagine, this thing is lumbering along at 45 watts just to stay on, so that when you click a remote control, you can turn on the set. But I rebuilt a couple of these remotes, and let's take a look at this. So it's everything works really well now. The mute button works. And the channel changer works. I'll show you that in a second. The set's taken a lot of time to get it up and running, but it does work, and it works actually quite well. Even though it doesn't look like it there. We're on the wrong channel. We are on channel 10. I was watching something else. So let's go to our remote. I've got it preset for 10 and 4. Should be channel 4. And that should give us a picture. That isn't too busted up because of the digital cable thing. I just want to say thank you, FCC, for this wonderful thing known as digital over-the-air transmission. It's really done so many great things for society. I don't mean that at all, actually. So let's hit the mute button here while the set's running. And what we can see here is that was channel up, and this is channel down. So we've seen all 4 functions, and it's really working well now, but it probably took me 3 or 4 days to figure this out. And I just wanted to share some of that with you and go over this before I wrap up the project and put the whole thing right back into the cabinet. So what I did, well, let me come over here and let's start at the beginning. The Zenith service manual is marginally helpful. The SAM's actually was more helpful. What's interesting sometimes is when you look at a schematic, in this case this is the 53954, 5391. This is the 53914. Nope, 53194. Space Command 400 chassis. And it's interesting when you look at one draftsman's interpretation of a schematic versus another. And I've been kind of favoring the SAM's schematics. They seem clearer to me just the way they're laid out, but I'm not an electrical engineer. I'm just a garage hack, I guess. But let's just go off of this SAM's schematic. This Space Command chassis is a 400, and so therefore there's 4 channels of control. And there's 4 relays in here. 2 of them control channel up and channel down, clockwise, counterclockwise. And the one operates the mute, and one operates the volume stepper. There's 3 volume steps, and then off. So this one does the most, on, off, and 3 volume steps. And, well, it just started to slowly fade in its functionality. And at first I thought it might be some of the caps that were going. I did change some caps. I replaced this electrolytic, and actually it did help. It brought up the negative source closer to where it should be on the schematic. I replaced one of these. It's a 0.047. I don't think that really did much. I don't think it was really bad. And I replaced a couple of resistors, but there was one resistor that was totally baked. This 47K was something like half a meg, so it was way off value. And once I replaced that, it brought this grid voltage up to where it should be. So that was a big part of why it wasn't tuning properly. So what we have here is a circuit that there's two tuned discriminator circuits. The first one functions around 40.75 kilohertz, and the second one functions at 38.25 kilohertz. And it's a process of, and then there's another coil that passes. It's tuned differently, tuned at 39.5, so I guess it's kind of in between the two. So you tune this one to allow maximum transmission of signal, I guess. And then you tune these in step to maximize their efficiency within these resonant circuits. So what we have, come in with the microphone, we have 2 stages of amplification. We go through this a coil that's tunable to pass just the bandwidth that's necessary. There's a 3rd stage of amplification. They call it a limiter and tripler. I suppose it limits the amount of signal that can get into this part of the circuit. And the heart and soul of this really are these 2 tuned coils. 2 of them are the bandpass coils, and then these 2 are the traps. And when each of these circuits is running at resonance, in this case 40.75, this one 38.25 kilohertz, as reference to the center tap on this transformer coil, you have current flowing in both directions, and there's a balance on these 2 plates of the diode. So you have 0 voltage output. And when the remote is activated, you have one channel that is tuned, and it's, in fact, I even wrote it here. You have the resonant, in this example here, this circuit, the 38.25 kilohertz circuit. We have one chime on the remote running at 37, well, roughly anyway, because there's harmonics involved, but 37.75 kilohertz for the on-off volume step. And then we have the mute running approximately at 38.75 kilohertz. So the peak resonance is right in between these 2. So when you have a circuit like this that runs, in this case when I'm saying running, I mean the being activated by the chime inside of the remote. If you're above or below resonance, it produces a voltage on one side or the other of these diodes. And when there's a voltage on this side, it activates this relay. It brings this negative grid voltage close to 0 and allows this relay to pulse until the resonant of the chime in the remote fades away. And if it's running on the other side of resonance, it activates, it puts a positive voltage here on this grid and activates the other channel of this resonant circuit. So the circuit runs, it gets 2 channels of operation out of 2 chimes by either running at a frequency or oscillating at a frequency that's either above or below the tuned resonant frequency of the coil, the input coil, the bandwidth limiting coil. So we have 2 separate circuits. They're identical in their design other than just the coils. And that's how we get 4 channels of operation out of this. That's the long story short. So there is an alignment procedure, not there. There's an alignment procedure here in the SAMs, and I started to follow this. When it stopped working properly, I broke out the signal generator and the scope, and was looking to tune it all up. So the high side of the signal generator is intended to go through a 100K resistor. We tune the first bandwidth coil, and this tells us where to put our probe, our voltmeter probe. A VTVM is what they recommend back when this was printed, and the high side of the probe to go through 1 meg. And then at the 47.5 resonance, you tune this coil for maximum deflection, and then at that same resonance, you have to not make the mistake of leaving that 1 meg in the reading. What you're doing there is you're taking it off. You're looking for a null reading, or a negative. Well, not a negative, a null. Looking for a void of signal, and that would be the balance between this part of the circuit and this part of the circuit. There's a voltage divider here. So you should have 0 volts between these 2 points when you're looking to adjust the trap. And then above resonance, you have one side that works, and then below resonance, you have the other side that works. So it was a whole procedure, and I probably had to do this 5 times, and it took me that many times to read the instructions enough to see that you take the 1 meg out when you're adjusting the null reading, because if you leave it in, you're adjusting it incorrectly. So, yep, my mistake. I used a lot of the voltage readings on here to sort of troubleshoot a couple of the resistors that were no good, and then the alignment procedure was well, it was pretty clear. You just had to do it properly. That's the 1 meg resistor that But in this case, I'm taking the generator signal out, and I could generate the frequency that I was looking for based on the SAM's instructions. So you can see what I'm doing here. You can go up and down. You can get a very precise signal. Now the chimes have a harmonic to them. It's pretty close to what the frequency is described at here. It's pretty close to this. So got it to work. With the SAMs, you know, this is kind of all the information I had. The resolution is too low to really see any of the components. You had to really study the schematic and then study the underside of this chassis. The traps and the bandpass coils are listed here. You'd think that they'd all be in order, but they're not. So I took to doing this, writing each tube number on the chassis, and then I wrote the coil designation by the coils also. The trap settings are very sensitive. Just a quarter turn one side or the other of resonance is enough to make the whole thing not work. It just took a long time. In the end, I got it close with the alignment procedure, but I ended up having to simply just sort of experiment until I found the right tune on these traps. But it works well. And let's see what we have here. Let's turn it, take the mute off. And I'm actually not even, I'm pointing the remote at the other end of the chassis, and it should still work. Yep. So it's pretty amazing how sensitive this thing is. And the channel selector works as well. Got a little episode of Mannix going on here. Back to PBS. So that's it. Space Command 400 works pretty well, but like I said, it just gobbles up power. This thing is pretty warm, and this transformer, I don't think there's anything wrong with it. It's just really hot to the touch. So I don't know. I couldn't imagine having this in a TV in your house, just on all day until someone decides that they're going to watch TV. There's just so much energy, and there's so much heat that's being generated by that, even just the Space Command. And when this set is running, there's 220 watts being eaten up. But it's a great set. Really produces a great picture. So we're going to get this thing back into the cabinet. Well, before I put the chassis back into the cabinet, I've been a little bit hesitant. First of all, I'm sure the reason is that I know that if I spend the next 2 hours putting the chassis back in, and the Space Command and the buttons and hooking it all up, that as soon as it's in place, something's not going to work right. So I don't know if I can get around that at this point. There really is no access underneath the chassis in the cabinet. So really, if it doesn't work, you're kind of stuck with taking it back out. But the other reason why I'm hesitant is that I'm not sure if I've properly strengthened these strips that go along the top and the bottom of the cabinet. Now, this is a beautiful cabinet. This cabinet is solid wood and high quality plywood, but there's just some things that never really worked very well on it in terms of restoration. So these tracks, there's a track that went along the bottom, and these doors would come in and close up like that, and then there was one on the other side and would close up, and there was a center stop that would stop it. So the set would look like this when it's just sitting there. But these, and it kind of works. I mean, I'm gonna just leave it the way it is. But they don't work very well, and these strips have now been, I don't think it's wood. I thought at one time these were just strips of wood that were cut. This is a piece that broke off. It actually should be double height. It should be this high, but it isn't. And it didn't respond very well to wood glue. It just would break off. And when I first picked up the set, the doors were pretty much stuck in place. This material had a white powder on it, and it's brittle. And I'm beginning to think this is not wood. This was some sort of synthetic. Maybe there's some sort of a nylon string with some material around it that could be flexed into place. Anyway, I tried wood glue. Wood glue didn't work. I tried some colored glue, which gave it this darker color. And I tried epoxy. That didn't work very well. So ultimately I used JB Quick, and that worked all right. But it's just really an ugly repair job. I'm gonna try to sand this down a little bit more and give it some, I guess, Sharpie it, just to keep it sort of dark in tone so you don't really see it. And yeah, really cool. You know, I don't know if this is a style that I really like, but it's an awesome cabinet. Just the quality of this is amazing. So, all right, I'm going to work some more on these strips and gonna get the chassis, and we'll start that process. right, well, I made another decision. I was gonna recloth these panels here, and I think it's gonna turn out nicely. The old cloth was it was a very similar tone. It has the gold snowflakes or whatever in it, but it was crooked, and I was going to try to straighten the fabric out on the panel, and then I guess I could have, but then I got into it. I decided that I kind of like this this Tolex material. Kind of matches the tones and everything, so that's what we're gonna do here. I had also had to take the speakers out because the voice coils were rubbing, and it looks okay now. I made a new dust cap, but ultimately when I took the speakers out, they were cracked around the edges. They're paper cones. So I used some flexible fabric glue. I know that they make glue for speakers, but this is what I use. Flexible, stretchable fabric glue. And that worked really well, actually. So I created some shims. I had the dust cap off, and I created some shims. Placed them in there because they were definitely, these cones were out of alignment, and I don't know what's going to happen when I put way too much time into these speakers. Yep, should be fine. And the tears in the paper, well, that's just the way it is. The glue, I got glue on the easy to get to side and kind of to the hard to get to side. So yeah, speakers. I had to do some gluing because when I took the fabric off, I discovered that the plywood had delaminated, so I put some wood glue in there. And well, I've coated this this other panel, and you can see the adhesive on it. They say let it dry for 15 or 20 minutes, no more than 2 hours. Just needs to become glossy and not tacky. And then I coated the backside of this piece of Tolex, and it's tough to not get globs of adhesive on here, because then it leaches through the material and you start seeing it on the front. So I'm going to keep it on the lighter side and press it together in just a few minutes, and I'll show you how I work it in. I'm going to put something down in between the rest of the panel and the surface of what I had just adhered. Just lining up the marks from what I had done before, and I'm going to press this one edge down. Yep, it's got nice adhesion to it. I run my thumb along from the center outward, trying to stretch it. And then we gotta stretch it this way also. And we're gonna use that envelope to kind of prevent it from tacking itself down prematurely. So, all right. So I'm going to pull this envelope out, and the idea is that I'm just going to try to tack this down. I'll move it out from a point where it doesn't leave wrinkles. But because of those open areas, it's not as simple as I thought it was going to be. looks like it'd be pretty easy to distort the pattern on this material if you don't pay attention to it. All right, I'm gonna pull this out. And I'm gonna try to pull this straight by eye. And you can just see as I push it down, it's distorting. We want to distort it into a straight line. It's gonna work out all right, I think. Right here, there's a wrinkle or an irregularity. Yeah, see, this is the open area. And it just doesn't, I don't know. I suppose the more you do this, the better you'll get at it. I had said at one time that I had not fallen in love with this set. It was just a project and an experiment. But in fact, that's not true anymore. I have fallen in love with this set. I put too many hours into it. It's really beautiful. And I gotta let go of it soon. You know, think about contact cement. Or just buy the proper Tolex contact cement. But I'm gonna put them in and back in the set, put the speakers on it, and hopefully that'll be that then. All right, well, I've got this second speaker panel installed. That's what it's like without the speakers in. I did want to show you this once I took this off the panel. This is the tweeter. These piezoelectric tweeters that Zenith used in the early 60s. Yeah, not much to it. Kind of an interesting choice.
This is an easy way
and
to
I have to say,
we do have more pieces that go with it.
I have to say I was really surprised that if you fool around long enough with the adjustments, you can get the buzz to go away pretty well, at least with this set. Not everything, not all the buzz on all the channels, but a big part of it is not only the fine tuning.
This is a piece that I remember.
That's part of it, is the fine tuning. But if we come around to the back and get into it, these adjustments here are really the two adjustments that seem to make all the difference. There's an additional coil. There's several coils in here. Over here by the video detector, this one right in there is the intercarrier adjustment, I think. But it's these two. This is the buzz control here, and then that's the quadrature coil. So quite literally, I found, and I'm not going to adjust it because I think it's pretty good, but quite literally, I would have an adjustment device, meaning a adjustment device in both of them, and tune them back and forth at the same time. And it's kind of an interactive thing. And between those two adjustments and the fine tuning per channel, you can get most of the buzz to go away. Certainly, I think good enough. And then you can enjoy the full fidelity of the dual 6x9 speakers and the tweeter up there. This is really an awesome set. I had said that there was some wadding that was stuffed between the frame of the speaker and the cone, who knows how long ago, in an effort to prevent it from rattling. And I just happened to find it in the box. So there was quite a lot of stuff jammed in there. That was by far no way to actually fix the problem, but maybe if it worked out well enough for the time, but it just distorted the cone in the opposite direction, so it created another problem later on. So anyway, that's what was in there. This was stuffed in there. So everything seems to sound pretty good now. Both speakers working much better. We talked about the doors not sliding very well on the track. Well, the tracks continued to just disintegrate. I tried gluing it and I can't stay ahead of it. So I think what I'm going to do is go back a few steps. I picked up some of this aluminum strip. It's 1/2 inch wide by 1/16 of an inch thick. They only had it up to 36-inch strips, but I think I'm going to use that material to try to make some new tracks. Just didn't stay glued down. And of course, I know that it's not going to be easy to get out. Just because it's rotten and disintegrating doesn't mean that it's easy to get out. So I suspect there's going to be some chiseling, and there's a lot of glue. There's a lot of glue. And then the top one was also falling apart. Let's see. Yeah. But that doesn't remove the whole strip. That's just the top part of it. Well, I think this is just more of a demolition project at this point. I've got a plan on where I'm going to go with this, so I'm just going to pull this stuff up and just get at doing it the right way now. Very handy having the speaker panel out. Here I was complaining about it. So much glue. It's just all glue in here. All right. I need a tool for that. And then on the top here, I had to re-glue this with JB Quick. It had fallen apart just like that, so we're gonna get this piece off also. You can just see it. This is a good choice to do it. I've fallen in love with the set now, and I want to make it right. Might need a tool here also. Well, I can't really believe this came out so easily. This was the top piece that I thought was going to be impossible to get out, but I used some brute force, some pliers, and pulled it down, and it just fell out. So this is the top track. It's, I don't know. It doesn't really matter what it's made out of. It's just interesting what they did. And hey, and but we do have a nice template for the shape. Look at that. Look at that. Look at that. Hey, who keeps putting that pliers there? Look at that. Well, look at this. I got one piece in, or at least a temporary test. But it's going to work out really well. This is a that strip of 1/2 inch wide by 1/16 of an inch thick aluminum strip, and the top piece went in really nicely, easily, because that wooden strip just came out with the pull of a pliers. So that's nice. So we got to do the bottom. Let's make up this, and yeah, I gotta clean up a lot of this, but we're gonna make a bottom piece, and I'll show you how I found the radius, or approximately the radius. Well, I'm trying the old jam a screwdriver in there and force it method, and it seems to be working all right. It's just gonna take some time. I think I have a new clever technique here. Just taking a piece of the aluminum strip that we're going to use, and using that as the scraper tool. What a clever idea. Okay, so when that stuff sits in here then, it'll maybe sit something like this. Well, this was the first strip that I bent. And it will fit in the top or the bottom slot. So this is kind of our go-to idea. And we're gonna make another one. So I found the radius, roughly speaking anyway, by I laid out the good strip that still existed and found a compass in a box that it had and basically determined the radius this way, both sides. The radius of these two corners is somewhere in between the diameter of this Bluetooth speaker and this roll of tape. So the tape is just a little bit bigger than the speaker. And so that was kind of my go-to guide by doing that. And I had measured out that the distance, the straight line portion between the two radiuses on the strip is about 25.5 inches from here to here. And then that radius would begin at that point, radius out. And then of course I'm gonna have to join some strips at the back end of it because this is only a 36-inch strip. So anyway, just a little basic stuff, a little basic math, and here we go. So just to start this, what I was doing is I was just finding that point and I started bending it with my hand and just slowly working it along, and it works out pretty well. Then I'll use the actual form in the cabinet to do the rest, but you can get the idea. And since I really don't care about this Bluetooth speaker, I was just kind of putting it on there and give it the old Tweak-O-Matic. And it actually works out pretty well. So I was going to do the same thing over here. Same thing. This aluminum is pretty soft stuff, the alloy. I don't know what it is, it didn't say, but it's pretty soft. Softer than 60, 61 or something. It's softer than that. So that's the idea. And then I was just gonna work it in using the cabinet. So let's do that. This is what we ended up with in our first crude attempt. And then I'll just sort of slide it in here. And surprisingly close. It just sort of drops into the groove. And we just give it a little bendage. Probably need 2 hands, but that's the idea. So we just bend it to the slot that's there, and the just that radius is not perfect, so therefore it actually tends to keep this strip right in place. I don't know if we even have to glue anything. This can't stick up too far because the inside of that door, the little groove, will run along the top edge of this, which it wasn't doing before because that wooden strip had broken. So this is where the door will glide along that strip, and we want the top edge of that aluminium to ride along the top edge of this ridge, but not a lot of room because both top and bottom doors have to have that. So we have to determine what the well, I think it's just about gonna fall right into place. You can see the track before it's painted. That's the idea, that it glides along the top edge. There's just enough room. Probably could get that a little bit lower, tap it in with the handle of a screwdriver. And then up on top, it's the same situation. There's just enough space. Well, this is the idea. It's really turning out all right. The strip is on the bottom. The door is above the surface, so it's gliding right where it should be. And up here we have the strip. Plenty of clearance. Down here is something I've got to figure out though. This is the joint between the front piece and the back piece. Maybe some gluage will just keep it lined up, but that's seems to be, if there's anything that's an issue, it's that. And the same thing on top and bottom, both sides. So when it slides, I mean, it's just right. Probably gonna have to adjust the depth of the track a little bit, but I'm on the right path here. All right. Well, this turned out better than I really expected it to turn out. It is sweet. Just glides like it's on ice. I did use, like I said, I took the paint off and I used some white lithium grease just in the areas where you can't see it, and it is sweet. Really smooth. This is the way it's supposed to be. All right, gonna put it back together, get the panels in there, and this project is a wrap. Yay! It's done. It's done. It's done. I'm gonna replace the hardware here, something else, but look at how these doors slide, just glide. Look at this. Just like the day it was made. So this is the one remaining question. I'm not sure if I'm gonna paint this plastic trim piece. Maybe I kind of like it like that. All the years of the family just turning it up and down. But here it is. The old 1962 Zenith black and white console. It is a treasure. What a beauty. Thanks for watching.
Zenith, where the quality goes in before the name goes on.